Before Normal, I was working at Graphcore on a large-scale AI accelerator. Big companies mean more meetings, more layers of management to get your ideas pushed through, more discussing things that aren't really to do with the engineering. So that was the push. And then the pull with Normal was having seen the technical challenges we were struggling with, power consumption, the sheer scale of things, where this stuff goes 5, 10, 15 years from now, and how we're reaching the plateaus of what you can do with what we've been doing for the last 30 years to address those problems. And Normal was suggesting a way of thinking about it completely differently, a novel way that, to be honest, I didn't fully understand, which was part of the excitement.
So what's different about verification? The fundamentals are the same, but what we are changing and innovating is our application of AI to that space in all facets of that space in terms of comprehension of architectures, feature understanding, stimulus generation, test bench creation. And then what makes Normal truly unique, because we are also working on silicon, we are able to test our own verification EDA tools against the designs as we build them. And so we have this very nice closed loop where we can take feedback from the design work we're doing and feed that right into our tools and improve them for our own use and then for our customers.
For me, autonomy is if I'm responsible for the outcome, then I'm 100% responsible for deciding how I achieve that outcome. If I get an intercept in between those two things, if I don't have total control, but it's my fault if it goes wrong, I can't cope with that.
All of AI is built on GPUs. The diffusion models are inspired by a physical process, and we think there's a different way to accelerate these versus blind map models. It's hard, no one's done it before. This is stuff you can't read from a textbook, this is stuff you won't read papers about, but we're trying. We've got some unconventional ideas, and we've got a sort of goal that we're going towards, which is diffusion, and we're trying to marry those in the middle. You're going bottom up, so you get all the crazy advanced research from unconventional stuff, and we're also going top down from the application down. So you're very grounded to what the goal is, alongside having this sort of research flexibility. So I think that's quite different, and you don't really see this anywhere else. Yeah, I think you have to be unafraid to do something wildly different.
Yeah. The EDA side of thing is exposing me far more than I would have been if I was just a customer of EDA to all of the possibilities that I can go through. I'm already rethinking how we can structure the teams, how we can restructure the process we use to build chips. Working with the EDA side has just opened my eyes to how this stuff is already changing, how it's going to change, and how you need to be part of that change, otherwise you're going to be left behind.
I think I'm just attracted to the hard problems. I like doing new stuff, I like doing things that nobody else is doing, and I like doing hard things.
We've picked up 2 very difficult problems we're trying to solve, so it doesn't get a lot harder than this in some ways, and that's just exciting to be a part of, especially with the team that has the breadth of experience that this team does.
The great thing about the problem we're trying to solve is that you don't really compartmentalize it into that 9 to 5 thing. It just becomes what you do. And we think we're going to the pub to relax, but we end up talking for an hour about some algorithmic problem that
there's a whiteboard there, the whiteboard would be